Hi, Mr. Green here. I'm going to be taking you through the next lesson on the waves topic of the Combined Science GCSE for AQA. This is on paper 2 of the physics paper and it concerns refraction of waves. Our learning objective is to be able to draw diagrams showing refraction when a wave passes from one medium to another. Please pause the video whilst you write that as your title. Okay, we're going to start as we always start with some retrieval practice. 4 questions for you there. Please pause the video and attempt those questions. Okay, question 1. What's the speed of sound in air? The speed of sound in air is 330 meters per second. What's the wave equation? You want to give this as a symbol equation or as a word equation? Wave speed equals frequency times wavelength, or V equals F lambda. Lambda is the Greek letter, and that's what we use to represent wavelength. Question 3. What's meant by the frequency of a wave? Frequency of a wave is how many waves would pass a certain point every single second. So how many vibrations the wave would go through in every second. What's the period of a wave? It's related to the frequency. It's the time taken for one complete wave to pass a certain point. Okay, our learning outcomes today is we're going to be able to draw ray diagrams to show the refraction of waves as they move from one material to another, to know that refraction is caused by the differences in wave speeds in different substances, and to be able to draw wavefront diagrams to explain refraction. Okay, so to discuss refraction we need to look at what we call a boundary point, so between two media or two substances. Now when a wave hits a boundary between the substance it's moving through and a different substance, it sometimes carries on moving through that new substance. But the direction of the wave might change. This is what we refer to as refraction. We can see examples of it in the picture just there. Now, waves travel through different materials like air, like water, or glass. Now, when they arrive at the boundary between those two, 3 things can happen. First thing is absorption. So the waves might be absorbed into the material the wave's trying to cross into, or the energy from the wave is transferred from the wave to the energy store in the material. The second thing that could happen is reflection. The waves may just bounce back once they encounter this new medium, so they'd hit that and all bounce straight back. The third thing that could happen is transmission. The waves might be transmitted, and that means they can carry on travelling through the new material. If the wave hits it at a right angle, just like there, bang on, it will carry on going through it without deviating. But if it hits it at an angle, it will undergo what's referred to as refraction. Okay, quick progress check. Write a definition of those 3 terms: absorption, reflection and transmission. Pause the video whilst you do that. Okay, so first one, absorption. Absorption is where the waves are absorbed into the material. The energy is absorbed into the material as well. Reflection is when the waves bounce back when they hit the material. And transmission is when the waves carry on travelling through the material. When we talk about refraction, we're referring to waves that have been transmitted through the material. Okay, so drawing a ray diagram to show the path a wave takes. So a ray is a straight line that shows the path a wave like light travels on. We can show the path taken by this on what we call a ray diagram, and here's how we draw one. First off, you draw the boundary between 2 materials. That's that straight line bisecting the yellow box there. So that would be our boundary. Then you'd add something called a normal. A normal is a straight line that's 90 degrees to the boundary, and we draw that as a dotted line. Again, if light travelled along that normal, it would just pass straight through the material without bending. So that's our reference point for everything. Second, we draw our incoming ray. Our incoming ray is referred to as the incident ray, and that meets the normal at the boundary. So we have it hitting there, and it will hit the boundary right at the bottom of the normal. The angle between the ray and the normal is referred to as the angle of incidence. So our incident ray hits the boundary right at the point where we've drawn our normal, and we can measure our angle of incidence there. Then we draw the refracted ray on the other side of the boundary. The angle that the refracted ray makes with the normal is referred to as the angle of refraction. We can see there, as it's gone from material 1 to material 2, the angle of incidence is much bigger than the angle of refraction. There's two examples of our ray diagrams. First one, we can see the angle of incidence much bigger than the angle of refraction. Second one, angle of incidence much smaller than the angle of refraction. Now that depends on what it's passing to and what it's passing from. What happens at the boundary then depends on the optical density of the material. Optical density is a measure of how quickly light travels through it. The higher the optical density is, the slower the light will travel. So if material 1 has a lower optical density than material 2, so from the diagram here, the material at the top and the material at the bottom, the wave will slow down and decrease wavelength. So if it's going into a material that has a higher optical density, the wave will slow down and the wavelength will go lower. This causes the wave path to bend towards the normal. If it's the other way round, and material 1 has the highest optical density and it's moving into a material that's much less dense, then the wave would speed up and increase its wavelength. What this would cause is the wave path to move away from the normal, so it would bend away from the normal. Okay, quick questions there. Pause the video whilst you answer those. Okay, question 1. What's refraction? Refraction is when a wave changes direction as it passes across the boundary between two materials at an angle to the normal. Question 2. A ray diagram to show the refraction of a light wave crossing from air into a glass block at an angle to the normal. It would look like this. Okay, so again that light ray hitting it at the base of the normal, going into the glass, because glass has got a higher optical density, it will bend towards the normal. Question 3. What happens to the path of a wave if it crosses the boundary between two media travelling along the normal? Its path will not change direction, it will carry on straight through. Okay, refraction occurs because waves travel faster in some materials than others, so the speed changes as it crosses the boundary. When a wave refracts, its speed changes, but its frequency remains the same. Wave speed is equal to frequency times wavelength. Since speed, frequency and wavelength of a wave are all related from the wave equation, if the speed changes but the frequency stays the same, that means the wavelength must also change. If the speed of a wave increases, its wavelength increases. If the speed of the wave decreases, its wavelength decreases. This is only if frequency remains the same, as it will do for the examples we have here. Now, wavefronts are what we call imaginary lines that are drawn through certain points on a wave. So if you can imagine on the diagram there, each line there represents the crest of a wave. Okay? It shows light travelling along the normal to a boundary. Now, the less optically dense material, we can see the gap between the two wavefronts is quite large. As it moves into the more optically dense material, the gap between each wavefront has got smaller. This shows our decreasing wavelength. Now, wavefront diagrams are really useful for explaining refraction. When the wave moves across the boundary into a new substance at an angle, one end of the wavefront enters the material before the rest of the wave. So that end changes speed before the rest of the wave, and it causes the wave to change direction. Look at this example here. The wave slows down at the boundary, it bends towards the normal. Those wavefronts, half of it, or some portion of it, is hitting the more optically dense material first and slowing down, whereas the rest of the wave's carrying on at the same speed. It causes it to bend and bend towards the normal. But if the opposite happens, if it's going from an area where it's more optically dense to less optically dense, the wave speeds up at the boundary, it will bend away from the normal. So some of that wave speeds up before the rest of them, causing it to bend. Okay, quick progress check on what we've learned so far. So pause the video whilst you answer these three questions. Okay, question 4. What happens to the speed, wavelength and frequency of a light wave as it crosses into a medium with a lower optical density? Well, the speed would increase, the wavelength would increase, but crucially the frequency doesn't change. How is decreased wavelength shown on a wavefront diagram? We show that by the wavefronts being closer together. Distance between two wavefronts would be the wavelength. Question 6. Describe the refraction of a wave that crosses the boundary at an angle to the normal and speeds up. If it speeds up, it bends away from the normal. Okay, final two questions for this one. Number one, draw a ray diagram to show a light wave hitting a boundary between two substances with an angle of incidence of 40 degrees and an angle of refraction of 60 degrees. And question two, choose the correct word to make this statement true. The wave in question one slows down or speeds up as it enters the new substance. Pause the video whilst you attempt that. Okay, so the ray diagram you should have drawn should look like this. Our incident ray hitting, again, the boundary right at the point of the normal, and that should be hitting it at an angle of 40 degrees to the normal. As it's gone into that substance, it's bent away, so it has sped up, and that angle should be 60 degrees, okay? Question 2. What's happened then? The wave has done what as it entered the new substance? It speeds up, and we can see this because it bends away from the normal as it exits. Okay, hope that lesson was useful for us all. Plenty of videos available on our YouTube channel. Please have a look, use that to revise and go through any information that you're not sure of. Thanks again for watching. See you soon. Goodbye.